How to build a deck with Tanalised E treated timber. Hi, my name is Titch. I'm here to take you through the basics of building a deck with Tanalised E treated timber. A simple step-by-step construction guide that will help any enthusiastic DIYer design, plan and build that extra outdoor room with the latest generation of preservative-treated timber. So let's get underway and show you how my friends and I are going to transform an area of my garden just over here. This is it, our decking site. A sloping area hardly ever used by my family, but by the end of the week we will have transformed it into a fantastic new recreation facility, a place to relax and have fun. Right, let's get down to business. Timber decking is as popular as ever for creating a versatile and beautiful extra living space in our homes. Decks provide a space to relax, an area to play, a place for dining outdoors, an extension to our living space. Wood is best. Timber is still our most adaptable and only truly renewable construction material. Properly protected, it provides the perfect long life, low maintenance and economical choice for our decking. Timber also has a natural beauty and warmth, making our deck look and feel attractive. What is Tanalised E treated timber? Tanalised E treated timber provides us with an economical, versatile and long-lasting material for our decking project. It is pressure pre-treated with the latest generation wood preservative, manufactured and supplied by Arch Timber Protection. This provides total protection against wood decay and insect attack, together with a long and low maintenance service life. It can be used with confidence for both in and out of ground contact applications. And Tanalised E treated timber is used by leading timber companies to manufacture their decking components. Designing and building a low-level domestic deck to an acceptable standard of construction, appearance and performance is well within the capabilities of the DIY enthusiast. However, for the construction of decks over 600 mm above ground level or for commercial decks, we do strongly recommend employing the services of an experienced professional deck builder. For further details, contact the Timber Decking Association on 01977 712 718 or at www.tda.org.uk. Tools and equipment. The following is a list of tools and equipment that you are likely to need for your decking project. If you do not have all of these tools, they can be hired for the duration of your decking project. Fixings. To match the long life and low maintenance of your decking timbers, high-quality corrosion-resistant deck fixings are recommended. A wide range of professional deck fixings should be available from your decking supplier, including bolts, screws, nails and various brackets. Safety first. Before we start our project, just a quick look at some of the safety aspects we should always remember. First of all, we recommend the use of safety glasses when using power tools and a dust mask when cutting timber. Also, when cutting timber, work in a well-ventilated area. When handling and working with timber, wear gloves wherever possible. Always use good hygiene practices when carrying out DIY projects such as this, by washing your hands thoroughly, especially before eating or smoking. Take care not to burn offcuts of treated timber. Do not burn treated timber offcuts in barbecues, cooking stoves or grates. Dispose of them safely as refuse. Wear goggles when pressure washing or scrubbing decking area with cleaners or restorers. During the project, keep children away from the work area until the job has been completed and tools have been safely stored away. A consumer information leaflet for Tanalised treated timber, which covers its general use, is available within the Documents section of this CD. Updated versions are always available from the Arch Timber Protection website, www.archtp.com. This illustration highlights all the components that are used in deck construction and will be referred to in this presentation. Notice that the subframe is made of several components: support posts, support beams, joists, noggins, and Newel posts. One important thing to bear in mind is that the deck boards run in the same direction as the beams and across the joists. Deckboard designs. Different decking suppliers offer varying deckboard designs to give you a wide variety of choice. Some boards have plain, smooth surfaces, and some offer a combination of smooth and profiled surfaces. The width and thickness of deckboards also varies. Generally, the narrower and thinner deckboard designs will require more supporting joists to support the boards within the deck design. Your choice of deckboard design will therefore have an influence on your subframe construction. This will be covered later in this presentation. Newel posts and balusters. Decking suppliers will also offer a choice of Newel post, handrail and baluster or spindle designs. These can be traditional turn posts, handrails and spindles, or more contemporary straight posts, rails and balusters. Fixing methods for each are slightly different, but the basic principle remains the same. Newel posts and balusters, together with accompanying hand and base rails, form an attractive feature or barrier around your deck. Our deck design. Methods of deck construction vary greatly depending upon the components used and the design and size of the deck. For the purpose of this presentation, we will be constructing a double-beamed, single-level subframe on support posts over a sloping site. The deck will also have Newel posts, handrails and balusters, a combination of smooth and profiled deck boards, and will feature steps down into a garden area. Many of the construction methods we show you will be able to use or adapt for your deck design. There are 6 basic stages to building our deck: planning and designing, preparation work, building the subframe, fitting handrails and balustrading, fitting deck boards, fitting steps. First of all, consult Decking and Lifestyle books or the Timber Decking Association website, www.tda.org.uk. They will provide you with lots of ideas for your deck. Then select the location of your deck carefully, having regard for privacy and the weather, sun, shade, and the direction of the wind. Consider the access to the deck from your home, including safe and easy access for the disabled and for children. It is advisable to keep the deck size in proportion to your home and garden. Draw an accurate plan of your deck design. This will help in the construction process and will help you and your decking supplier to confirm the component quantities you will require. Remember, if you are constructing your own deck, you will need good basic DIY skills to achieve the desired quality of construction, appearance and performance. For all but a simple low-level deck, you should satisfy yourself as to whether planning and building regulations apply. If unsure, always discuss your intentions with your local authority planning office, as well as your neighbours. Consider the end use of your deck. You may need to beef up the design and build to commercial specifications for large groups of people, or if a hot tub is being designed into the deck. And be aware that building regulations require that any deck of more than 600 mm above ground level shall incorporate Newel posts, handrails and balusters for safety purposes. Preparation work. Within the deck we are constructing, we will be utilising a low garden wall and steps from the patio area. We will also be incorporating an existing magnolia shrub as part of the deck design. Including features such as these helps to blend the finished deck into your existing garden environment. Once your design and planning work has been completed, using the deck plans, roughly work out your deck area and mark the site with timber stakes and string. This will confirm the size and position of the finished structure. It will also help confirm its scale to your home and garden and its relationship to other garden features. Generally, the vegetation covering the site should be cleared. However, turf can be left in position so long as you're applying a weed membrane to the full site and covering the membrane with pea shingle. The pea shingle will cut out any light to the membrane and maintain its function. Rolls of membrane are available from your decking supplier. Pea shingle is available from your decking supplier or your local builder's merchant. On our decking project, because we are using support posts for the subframe, our membrane will be laid over the turf after the construction of the subframe. Using a measure, accurately determine the position of the deck support posts from your deck plan. These posts will support a pair of beams, which will form the main structure of the deck subframe. Mark their positions using a timber stake. On our deck, we will be using 90mm by 90mm size posts. Check that the positions of the support posts are accurate and square to each other, and to other structures that will be surrounding the deck. A simple way of ensuring right angles between these post positions is to use the 3-4-5 triangulation ratio method, using timber stakes and string. Once you have accurately located the position of the support posts, use a narrow spade to dig a 600mm deep hole at each position. Each hole should be roughly 200mm across. Line the base of each hole with a 25mm layer of pea shingle. This will allow a firm, well-drained base for each support post. Building the subframe. Support posts are different to ordinary Newel posts in that they must have been preservative pre-treated to a higher level of protection to allow for the post being used in ground contact. This is very important for the long-term performance of your deck, and you should check this fact with your decking supplier, making sure that any other ground contact timbers also have this level of protection. On our deck design, there will be 4 beams. The distance between beams should be a maximum of 1800mm. However, depending upon the intended use of your deck, these beam distances may need to be significantly less to provide extra strength and stability. The position of the beams will be determined by the joist size, which in turn is determined by the unsupported distance they have to span. Your decking supplier should be able to advise you here, or you can refer to the leaflet showing beam and joist span tables within the Documents section of this CD. Our beams are constructed using 150 by 47mm joists, fastened to either side of the support posts. We now need to cut the support posts to the required size. If you have a level site, all your support posts will be of a similar length. Because we have a sloping site, the length of each post has to be determined. A useful tool for achieving a general measurement is an infrared spirit level. From a fixed point on your deck site, an infrared beam can be projected onto each support post held in position within its hole. The point can be marked and each post cut. Alternatively, each support post can be concreted into position and then cut to size prior to attaching the beams. Here, the 3-4-5 triangulation method of creating a 90-degree angle will help ensure your post positions are square and accurate. When cutting the top of each support post, cut at a slight angle. This will allow rainwater to drain off the posts. Use N-Seal Brush-On End Grain Preservative to seal the cut made to the timber. It is best practice for the opposite end of the post, which will be in ground contact, to be left uncut. If it has been cut, this too should be brushed with N-Seal. Throughout your decking project, all cuts and notches made to the treated timber should be sealed with N-Seal, available from your decking supplier. The use of N-Seal forms part of the performance warranty of Tanalised treated timber. Therefore, it's very important to carry out this procedure. When applying N-Seal end grain preservative, always follow the instructions on the can. The initial blue coloration of N-Seal will quickly change after application to a pale green to blend in with the treated timber. A leaflet on the use of N-Seal is also available within the Documents section of this CD. To construct our beams, we used 150 by 47mm joists, fastened to either side of your outer support posts. This fixing should be temporary at this stage and made with screws. Position the beams, with the outer support posts attached, into the holes and check the beams are roughly level to each other using a long spirit level. Height adjustments can be made by either hammering down the support posts to drop the level or adding extra P-shingle under the posts to raise the level. When constructing the deck, you should allow a slight fall in one direction, usually from back to front or to the side. This should be a minimum of 1 in 100, allowing adequate rainwater drainage on the finished deck. If you are using grooved deck boards, these should be laid in the direction of this fall to ensure water drainage. Intermediate support posts can now be temporarily fixed with screws at the centre of the beams. Once a final check has been given to the level of all the beams in relation to each other, all the support posts can be concreted into position. Use a thick, dry mix of concrete and tamp the mixture down around the post. The finished level of the concrete should be slightly above ground level, with the surface bevelled away from the post to allow water runoff. These beam structures should now be left overnight, allowing the concrete to set. The following day, again check the levels of the beam structures to each other, with the drainage gradient in mind. Adjustments can be made by unscrewing, raising or lowering to suit, and refixing the screws. These fixings of the beams to the support posts should now be made permanent using 2 ledger lock screws or coach bolts. To add extra strength to the subframe structure, angled corner bracings made from support post material can be screw fixed to the outer support posts and up into the beams. Now that the support posts and beams are in position, we can continue to lay our membrane over the turf. Using an edging tool or spade, make an incision into the turf all around the outer edge of the deck area. Bear in mind that the position of this incision will be determined by the eventual position of your deck boards and fascia board vertically above the edge of your deck. Cut lengths of the membrane to suit, and with the edging tool or spade, push the outer edge of the membrane into the incision in the turf. Continue around all of your deck, laying and fixing the membrane. Ensure that the complete area under the subframe is covered with membrane. Make cuts to the membrane to go around support posts and any other structures or deck elements within the subframe area. Overlapping patches can be made if required, and fixed into position using metal staples. Once the membrane is in position, use lengths of treated timber battens or baluster material to form a shallow frame around the subframe. This will give an edge for the subsequent covering of P-shingle to rest against on a sloping site. Fix the battens using metal staples. On sloping sites, intermediate battens within the subframe area may also be required to prevent the movement of the P-shingle down the slope. Cover the whole area of the membrane with a 25 mm minimum depth of P-shingle. This will allow excellent drainage under your deck and will help keep the membrane in position and cut out any UV light, which can deteriorate the membrane material. Newel posts can now be fixed into position. These posts will provide the support for our handrail system around the deck. Cut the Newel posts to the required length, allowing for the depth of the subsequent top rails, bottom rails and balusters that will make up the railing system. When fitted, a maximum of 100 mm gap should be allowed between the top of your deck boards and the bottom edge of the base rail of your railing system. The bottoms of the Newel posts are fixed in at least 2 directions to the beams, using either ledger lock screws or coach bolts to provide a solid fixing. Once fixed in position, check that the Newel posts are level. For the corner newels, extra joist material is fitted between the beams to provide increased support. On our deck, we also fitted an extra Newel post into the subframe to accommodate our colonnade feature around the magnolia shrub. Intermediate joists can now be fixed onto the beam structures using 100 mm screws or 100 mm high-quality galvanized nails, fixed at an angle down into the beams. Again, we used 150 by 47 mm size joists. The distance between each joist will be determined by the section of the deck boards you're using in your deck design. Wider, thicker deck boards can have wider joist spacing. Narrower, thinner deck boards will require closer joist spacing. Decking suppliers will give advice on joist spacing for their range of deck boards, or you can refer to the joist spacing leaflet supplied in the Documents section of this CD. Continue to fix the subsequent joists across the beams. To maintain a consistent width between joists, a short piece of timber cut to size is a useful device. Once all the joists are fixed, noggins should now be fitted throughout the subframe. These are short pieces of joist material that are fixed between the joists to provide an extra rigidity to the whole of the subframe. Noggins can be fixed using screws or high-quality galvanized nails. We have also positioned noggins around the magnolia shrub to create a mini-frame that will provide support for the subsequent deck boards. Using screws, joists can now be fitted to the outer edges of the beams. These are known as rim joists. These will provide an outer edge support for our deck boards. Because our deck design incorporates an existing wall and steps, a ledger board will be used to act as an extra beam to fix the joists to. Ledger boards, cut from joist material, are screw-fixed to the wall and steps along their lengths. These boards should be packed away from the wall and steps by at least 10 mm, using either several washers around the screw fixing or galvanized bars. This allows adequate water drainage. If your deck is to be fixed directly to your house, a ledger board should be used and fixed in a similar way. However, the damp-proof course of the dwelling should never be compromised or bridged, which is why you often see advice to install decks well below DPC level, particularly where DIY installation is involved. But by following the details and procedures shown on the illustration, decking can still be installed to be level with an existing patio or French doors. We can now fix extra joists from the main subframe to the ledger boards to create our small subframe in the step area. Joist hangers and corner brackets have been used to fix and support the joists to the ledger boards. Our subframe is now complete. Fitting deck boards. We can now start to lay our deck boards. On our deck design, we will be using alternate smooth and grooved deck boards to create our required pattern. We have fixed the deck boards down the gradient fall, ensuring rainwater can drain freely along the grooves or the smooth profile. Measure the required length of your first deck board and cut to size. Remember to end seal the cuts on each deck board. Using 2 deck screws on each supporting joist, accurately fasten your first board 25% in from either side, lining up the screw positions for an aesthetically pleasing finish. Screws should be 2.5 times the depth of the deck board. We used 75 mm screws for our 33 mm thick deck boards. Now position and fix your next boards, leaving a 6 mm gap between each board. A good tip here is to use a 6 mm gauge nail or screw to provide a consistent and precise gap along the length of the board. Because timber is a natural material, this gap between the deck boards allows for initial shrinkage and any subsequent expansion of the boards, together with providing excellent drainage on the deck. Continue along your deck, cutting each deck board to size and fixing with 2 deck screws at every supporting joist along its length. If the deck board is to go around a newel post on the edge of the deck, measure the notching required, again allowing a 6 mm gap between the deck board and the newel post. Carefully cut the notch and fix the board into position. When fixing the very end of each deck board, it is necessary to pre-drill the 2 screw holes to help prevent the timber from splitting. When you get to the fitting of your final deck board, you may have to make several notches to go around the newel posts positioned along the length of the board. Remember to end seal all the notches. To provide a neat finish around our deck, lengths of deck board can be used to create a fascia. These fascias hide the cut ends of the deck boards, as well as the ends of the beams. Spacers made from short lengths of baluster material will be required along the length of the outer faces of the subframe to attach the fascia boards and provide support. The fascia boards are screw-fixed to these spacers and mitered at the corner joints. The spacers also allow a drainage gap between the ends of the deck boards and the fascias. We have incorporated our existing magnolia shrub into our deck design, and as with the cutting required to go around our newel posts, each deck board should be carefully cut to shape with a jigsaw before fixing in position around the shrub. Fitting handrails and balustrading. Now that our deck boards are in position, we can start to look at the handrails and balusters that will provide a feature around the edge of our deck. First of all, a top rail is cut and fixed to the newel post so that the top edge of the rail is level with the top of the posts. The rail can be fixed to either the inside or the outside of the posts, whichever is preferred from a visual point of view. However, fixing to the insides of the posts is advisable if you require improved strength to the railing system. Fix the rail with 2 screws to each post, making sure that your joints of rail are calculated to meet in the centre of the newel posts. Where the rails meet at the corner of the deck, mitre the joint for a professional finish. Further strength can be added to this mitre joint with 2 screws positioned horizontally. Base rails can now be fitted to the posts around the deck in a similar way. Remember that the bottom of the base rail should be no more than 100 mm above the top of your deck boards. A wider top handrail can now be fitted on top of the newel posts. The handrail sits squarely on top of each newel post and can be fixed using a metal corner bracket to the underside of the handrail and the inside face of the newel post. Make sure the screws used with the bracket are not too long to come through the top face of the handrail. Alternatively, the fixing can be made by screwing through the top of the handrail directly into the newel post surface. Once again, where the handrails meet at the corners of the deck, use a mitre joint for a neat finish. Balusters can now be fitted on the inside of the top rail and the base rail. Cut balusters matching the distance between the top edge of the top rail and the bottom edge of the base rail, less 10 mm at their base. The bottom of each baluster should also be given a chamfered cut for a professional finish. Balusters should be fixed with intermediate gaps of no more than 100 mm. You will need to work out the number of balusters for each section between the newel posts and their exact spacing to provide a consistent design. Once you've calculated this spacing distance, cut pieces of timber to use as a consistent spacer guide. Screw fix each baluster into the top and base rails using 2 screws in each fixing. Pre-drill the screw holes to help prevent the timber from splitting. Some decking suppliers offer specialist products in their range to allow unique features to be designed into your deck. On our deck, we are utilising short columns to provide a lower level railing system to make a feature of our existing magnolia shrub and allow for its continued growth. The columns are first turned upside down, positioned at the required distance apart, and a section of the rail is screw fixed to each column, with 4 screws, 1 in each corner. As we are creating an outer corner to our deck, the rail section is then mitre joined across the last column to a second run of columns. The mitre joint is again strengthened with horizontal screws pulling the joint together. This jointed section is now turned the correct way up and screw fixed in position on the deck boards with the ends of the rails meeting the newel posts. Corner brackets are used at the newel posts to provide a neat and solid fixing. The freestanding newel post, already built into the subframe, is carefully cut to size to match the height of the columns. Sections of top rail are cut to fit over the top of the columns with a mitre joint at the corner. The top rail is screw fixed down onto each column with a screw at each corner. Finally, sections of wider handrail are cut and screw fixed from below through the top rail. Each end of the handrail section, where it meets or overlaps the newel post, is given a chamfered angled finish with a chisel for a professional touch. Fitting steps. Steps for your deck are made up from 2 main components, strings and treads. Some decking suppliers offer strings pre-cut to the number of steps required, and treads manufactured to suit the depth of each string that simply require cutting to length. However, on our deck, we will be preparing our own strings and producing the treads from our deckboard timbers. In planning our deck, we have already positioned and cemented into the ground 2 newel posts, which will form the bottom posts for our steps. These are positioned equidistant and parallel to the newel posts that form the step opening within our railing system around the deck. On our 2 string boards, we mark out the position of the number of steps required using a set square and straight edge. Calculate and cut the top of the string boards to meet the top of the deck and top newel posts. Similarly, calculate and cut the base of the string boards at an angle to meet just above the ground and the bottom newel posts. Offer the strings up to the edge of the deck between the inner faces of the newel posts to ensure our calculations have been correct. Metal tread brackets can now be fixed to the inner faces of the strings. These will support the deck boards that make up the treads. Lay the strings down and fix the deck boards that make up the treads for your lower steps to the string brackets. This needs to be done at this stage, as once the steps are fixed in position on the face of the deck, accessibility for fixing the lower steps will be very limited. Secure the 2 strings to the top and bottom newel posts using ledger lock screws or coach bolts. Fix your top treads into the string brackets from underneath. If required, a central string to support the treads can now be cut to shape and added to the back of the steps to provide extra support and rigidity to the structure. Added strength can now be given to the treads by horizontal screwing into each tread through the side of the strings. With a tape measure and straight edge, measure and mark the angled cut required to the bottom newel posts to be parallel with the strings. With a handsaw, carefully make these cuts. Offer up a section of handrail to calculate the required length to overlap the bottom newel post and the angled cut required to fix to the top newel post. Once cut, fix the handrails in position with diagonal screwing into the top newel post and vertically into the bottom newel post. At the top, pre-drill the screw holes to help prevent splitting of the timber. Chamfer the corners of the handrail at the top and the bottom. Top rails now need measuring, cutting and fixing underneath the handrails. These top rails, together with the inside face of the strings, will provide a fixing surface for balusters to match the rest of the deck railing system. The top rail is fixed to the handrail with screws through the top face of the handrail. Cut the top of the balusters with an angle required to fit the angle of the handrail. Chamfer cut the base of the baluster to match the other balusters on the deck. Pre-drill the screw holes in the top and bottom as previous. Fix with 2 screws at the top and bottom of each baluster. Finishing touches. Some decking suppliers offer trellis components, which can be fitted around the deck base to provide a barrier to any debris accumulating under the deck. Trellis panels can be cut to the required depth and fixed in position with a simple capping system. Firstly, lengths of capping rail are fixed to the underneath of the deck fascia boards and on top of the battening that forms the frame around the membrane of the deck. A vertical capping rail is also fixed at the corner of the deck. Pre-cut trellis panel is now slid into position within the grooves of the capping rails. A joining rail completes the section of trellis with a free outer groove to continue the process along the length of the deck. However, my family has decided to leave the base of the deck open. It is an area that can be utilised for storage of garden equipment, or simply as a cool, shady resting place for me on those hot summer afternoons. Just to finish off, a few tips on getting the best performance from your deck and keeping it looking at its best. Some decking suppliers provide an extra built-in water repellent protection within the Tanalised preservative treatment of their timbers. This usually shows with a water-beading effect on the timber surface. This will help to minimise splitting of the timber. Brush-on water repellent products, such as Hixon Decor Wax Coat, are also available to maintain and refresh this protection, or to add an initial protection to standard preservative-treated timbers. You should always keep your deck clean, sweeping it regularly to remove dirt and leaves. Pressure washing can also help. A wide range of deck cleaners is also available from decking suppliers and DIY stores. For timber steps and decking timbers around ponds, clear aggregate brush-on products such as Hixon Decor Anti-Slip will help provide sure footing in wet weather. Should you wish to add colour to your deck, again there is a wide range of decking stains available, either through your decking supplier or from your local DIY store. Hixon Decor Wood Oil is just one example. A linseed oil-based product, it soaks into the timber surface and provides a high-performance water-repellent protection. A Tanalised green colour is available within this range to refresh the colour of the treated timber, if required. If you are adding any type of coating to your decking timbers, always follow the manufacturer's instructions on the can. And remember that these coatings will require regular maintenance. Well, that's it. Simple, wasn't it? Or was it? If you do feel the installation skills for the deck you want are beyond you, we do recommend working with a professional installer. You can still plan and design your deck and even play an active role in the deck build to improve your knowledge. But with an expert's input, you will end up with a quality structure that all your family and friends will enjoy. Finally, should you require details on your nearest supplier of quality Tanalised E-treated timber decking components, simply contact the Arch Timber Protection Advisory Service on the number below. And remember, a deck constructed from Tanalised E-treated timber is not just for Christmas, it can be for life.